Hello, how was yesterday's activity? I hope it was easy. Now we will continue with the factorization with the second part, which will be more examples of all of the special binomials and special products that we have been already practicing. Okay, so in first instance, let's recall ourselves that we had the common factor, which was in the form of taking what was common between the terms and putting a parenthesis outside. Here we can see that is ax to the n plus 1 and abx, which would be the common factor ax, right? Because I can take 1x of each of the terms, as you can see there. From the n plus 1, it means that you have an xn and an x1. That's why I am taking only 1x. Now, the difference of squares. So, as we saw yesterday, it would be a result of conjugate binomials, okay? So if I have a squared minus b squared, that would be a result of a minus b times a plus b, okay? Now, the next one that's new for today that we will be seeing and learning is the difference of, well, now it's not squares, but it is a cube, okay? So the difference of cubes, remember that when we had a difference of cubes as a result, it meant that it came from a binomial times a special trinomial. I don't know who of you remember that, okay? But remember, in this part of factorization, we're doing just the opposite. Instead of multiplying, we are splitting into its factors, okay? So that was a part of the binomial, and as you can see, if it's a difference, the first binomial has a negative sign, and the other is a special trinomial, okay? And it goes with positive signs. In the quiz, I remember that that came in your first squared the table of the quizzes, okay? Now we're gonna see the sum of cubes, okay? Which is just like that, yet the difference is that instead of being a difference, it is a sum. So I just came up with this little imagination of making two cubes being summed up, okay? So they're celebrating that they are being used again. Well, so we have a to the third power plus b to the third power, which would give us a result, a factor form of a plus b, and the trinomial, which would be a squared minus ab plus b squared. Watch out with this third sign that I am pointing. Why? Because it is negative sign, okay? It is a sum of cubes, but the sign must be negative so that it complies with the special product notation, okay? So always remember, guys, it is important to identify, once you're given a problem, which of these formulas can I apply? Which of these formulas is the one that fits in? Which would be my a cubed? Which would be my b cubed? Which is the a squared, b squared, which is a common factor, okay? And always do things orderly and in a proper and clean way. So now let's move on to an example, okay? So this will be the first example, which I'm gonna write just right now. 27x to the third power, y to the third power, minus 64. So let's ask ourselves, does that involve a common factor? Does that involve a difference of squares? Does that involve a difference of cubes? Or rather, does that involve a sum of cubes? Okay, so which of that does it involve? In the first instance, we cannot take a common factor because no variables and no numbers are the same. 64 probably has a square, but 27 doesn't. So we cannot say it is a difference of squares, but what about a difference of cubes? The numbers and the variables have a cube, okay? And it cannot be a sum of cubes because it has a negative sign, okay? Therefore, I will proceed with the rule for the difference of cubes. So, let's remember what was the formula for that. A cubed minus b cubed equals a factor form of a minus b times a squared plus ab plus b squared, okay? Which is a binomial times a special trinomial, okay? Now, what they are giving, it is the a cubed form, so I will put in the binomial the cubic root, right? Only the a. That would be a and b, but the cubed forms, okay? A cubed and b cubed. Therefore, my a alone would be the cubic root, which is 3, x and y, okay? That would be a by itself. And b would be the cubic root of 64, which is 4, okay? So I already have a and b, and I just follow my formula, which would be a squared, 9x squared, y squared. The next one is a multiplication of both terms, and last I would have a b squared, okay? So that would be 60. Respecting my symbols, all of the signs, okay? And if I cannot simplify further, then I move on to the next example. So this example is a multi-step example. It's not just about, identifying the fourth. And I'm gonna write it. It's 54 x to the m plus 3, sorry, y minus 250 x to the m y to the fourth power, okay? The first thing I identify is that I have a common term, okay? So I can advance with that and let's check what comes out of it. X is also a term, but they both have x to the m. That's why it is a common term, x to the m. And the y, I can also take it from both terms, okay? So as a result, I would have, if I take out that term, 27x to the third power, because I already took y, and 125 y to the third power, because I already took x to the n. Now I see this binomial. Can I simplify it more? Evidently yes. Why? Because I realize that this binomial represents a difference of what? Of cubes, right? Therefore, I'm going to open my binomial and the parenthesis for the special trinomial, okay? So my a would be this cubic root, which is 3x, and the b is the cubic root, which would be 5y. And my special trinomial, remember, I have my a minus b, and the special trinomial would be a squared, and then the signs plus ab plus b squared, okay? So a squared would be 9, right? 9x squared, and then the multiplication of both plus 15. Remember, the sign is only given there, okay? If they're telling me it is a plus sign, it is a plus sign. And 25y squared. Can I simplify that more? No, it seems not. So I have already completely factorized all of this problem, okay? Good luck, guys. Time to do activity 2.